All right, continuing on with our 1.1 notes, we have the definition for a function. A function is a dependent relation that pairs each input value with only one output value. Now, most of the time in math, you actually will be studying functions. So relations kind of get you into functions, and again, in most of math, you're going to be looking at functions. So that's kind of the big hitter for today. Now, in order for it to be a function, no x value can be repeated with a different y value. Okay. So here are some prime examples of seeing that in action. So we are asked to determine whether this relation is a function or not, and then give like a brief explanation why or why not. So as we look, we're trying to check and first see, do we have any repeating x's? Well, 2 is not the same as 3, and 2 is not 4, 2 is not 5. So this guy is okay. Now we move on to the next number 3. We don't see 3 repeat here or here, so this guy is okay. And then we get to 4. Well, we don't see any other repeats for 4. So this guy is okay. And then 5 is also alone. So there are 0 repeats, and you do have to confirm that for every single x value. Now, the answer to this then is yes, this is a function. This relation is a function because we have all different inputs. Even really that would be enough, but just to kind of add a little bit extra, all different inputs with an output. Now you might be asking, well, hang on though, Mr. B, what about right here where we see a different or the same output? Doesn't matter about the output. Okay, you can have a bunch of different inputs ending up at the same output. That's totally fine. It is the same input trying to go to 2 different places. So yes, this would be a function. Now let's go ahead and take a look at the second one. We have 5, 10. Again, this represents an x and a y. And then an x, comma, y, x, y, x, y. So we're asking ourselves, do we have any repeating x values that are going to 2 different outputs? So looking at this, our first one is a 5. Do we see any other 5s? Nope, we don't. So then we move on to the next number 3. Do we see any repeating 3s? Nope, we don't for the x values. Like this guy's good, and this guy's good as well. So 3 is okay as well, that second point. Now we move on to 13 for that x value. We don't have any other x values that are 13, so he's okay. And then finally, we look at 9. There are no repeating x values of 9, so yes, this relation is a function. So yes, this relation, pretty much repeating exactly what we just had for the red. This relation is a function because there are no repeating x values. Or x inputs. Okay. All right. Go ahead, feel free to pause the video if you have any questions on these two. All right, now we end up with a mapping diagram. Now for the mapping diagram, again, the first item is kind of like our inputs. So those are usually the x's, and the second one are the y's. or the outputs. Yeah, this is like your inputs. And these are acting as your outputs. So as we look and we see the first one is 4, we're asked, is 4 trying to go to 2 different places? Well, no, it looks like 4 is only going to -3. And then we end up with 3 trying to go to -5, but 3 is only going to one place. And then the last one, we end up with 2. Well, 2 is trying to go to -5, and 2 is also trying to go to -4. 2 cannot do that, okay? So as a result, is this a function? Is this relation a function? No. This relation is not a function. And then on quizzes and tests and homework, we do want you to be specific as to the why, because 2, or the input 2, has 2 different outputs. -5 and -4. Okay, so that would not be a function. And then our final one, here we have 2, 6. Again, that's like an X and a Y, an X and a Y, an X and a Y, and an X and a Y. So we have to ask ourselves, is this first X value 2 being repeated at all? Well, no, not here. Oh, wait a second, here. Yes, it is. So most of the time, like 99% of the time, this is not going to be a function, okay? And in this case, it is not a function. There's only one kind of trick scenario, and that would kind of more or less be a trick question from a teacher. I don't usually like to do that, but you could have someone do that to you, but it's pretty rare. In this case, most of the time, no, because our input 2 has 2 different outputs. And again, to kind of keep it more specific, it's going to 6 and 13. Now, a lot of times I like to give the analogy of when you're trying to determine if something is a function or not, think about people and places. This has usually kind of been like the thing that students reference because they can very much visualize people and places as opposed to like necessarily like a table. So let's dive really quick back up to here. We have 2, 3, 4, 5, and then 3, 4, 4, 6. This is saying, I'm just going to make up, this is like saying Cindy, an input Cindy is going to New York. Well, Cindy can do that. She can absolutely do that. Now, a completely different person, Matt can also end up in New York. Physically, that can happen, right? Now, let's look at the scenario where maybe that doesn't quite work. Just because we did this one a moment ago, let's reference him. You have this number 2. Let's say number 2 represents Sam. Well, Sam is we're going to make the number 6 LA. Can Sam do that? Yes, he can. But then all of a sudden, at the exact same time, Sam is trying to go to London. Well, Sam can't do that. Physically, he is unable to do that. And so as a result, that would not be a function. That is not doable. So you can have different people ending up at the same spot. It's trying to have the same person ending up in two different places. That can't physically happen. And so hopefully that kind of people and places analogy kind of helps distinguish yes or no, it is a function or it's not a function. Just think about people and places. Now, another one, though, a moment ago I said like 99% of the time, that is not a function. And here that's a prime example. Like Sam cannot go to two different places, right? However, again, this would be a trick question, but if you consider that was not 13, let's say that was 6. Well, earlier in the statement, we said Sam is trying to go to LA, right? Well, yeah, Sam can do that. And then you have like a different person going somewhere else. And then all of a sudden, Sam is trying to go to LA because it's 6. Can Sam go to LA and then later on, but also kind of at the same time, Sam going to LA? Yes, that can happen. That would be a trick question. That would basically be saying and repeating the same event, though. Normally in math, you will not encounter that, though. Okay, but you may have a math teacher sneakily trick that in. I personally don't, though. I don't like to do that. All right, what I want for you guys to do now is go ahead and pause the video, thinking again about people and places, though. Your kind of X value are your people, and your Y value are your places. Okay, ask yourself, can these people do that? Yes or no? So go ahead, pause the video, and try 5 and 6. All right, now that you guys have had the opportunity to try these, let's take a look and see how we did. Well, -2 is not repeating, but then all of a sudden we do see -3 does repeat. So that's not an automatic no if they ended up at the same spot, but it's definitely a red flag. So all of a sudden we see, hey, -3 is trying to go to 2, and at the same time, -3 is trying to go to 3. -3 can't do that. He can only go to one place. Again, an analogy, Mike is trying to go to Chicago, and then Mike is trying to go to New Orleans. He cannot do that. Mike can only go to one place. He can't go to two different spots at the same time. So this is not a function because -3 as an input has two different outputs. Two and 3. And so on the homeworks and quizzes, that's what we're looking for the explanation. Yes, you do have to explain those on those quizzes and tests. Next, number 6. Here we go. Again, here's our diagram map. These are the inputs. These are the outputs. These are kind of like your X's. These are your Y's. And so at first we see that 4 is trying to go to 5. Well, 4 can do that. Then you have a completely different number or person, you could think of it as, is also trying to go to the 5. That's okay. That can happen. You can have two different people ending up at the same place. That's totally fine. And then 12 is going to 10 and 16 is going to 15. Nothing really exciting with those. They're just going to their own little destinations. So is this a function? Yes, because each input has exactly one output. You don't have the same input trying to have two different outputs. Now, because this is a function, we do want to quickly reinforce this. What are the domain and range? Because you do use domain and range within your functions. So it looks like our first number would be 4, then 8, then 12, then 16. And then for our range, again, from smallest to biggest, looks like 5, 10, 15. You don't need to repeat the 5 because it's already there. Okay. You're going to find, though, like you're going to be determining whether it's a function or not, and then basically stating the domain and range on your homework questions and test questions. Okay. So if you did not have this jotted down, I would definitely pause the video and jot those down. All right. Next up, we have what's called the vertical line test. And the vertical line test is a super, crazy fast way to answer whether a graph is a function or not. And it happens so fast. You could literally answer these 4 questions in about 2 seconds. And how it works is a vertical line test is used to identify functions from graphs. A graph is a function if a vertical line intersects the graph only once. Okay? So it can, if you were to draw a vertical line through that graph, it can only cross once. Now, for example, on this first one, the moment I drew my vertical line, I see, oh, it crosses twice, crossed more than once. This is not a function. So this would be no for this first guy, not a function. And then your reasoning would be failed. So because failed the vertical line test. Now, really what I would love for you to do is pause the video and ask yourself, like, why does the vertical line test work? Like, what's the whole idea behind, it succeeding or failing if it only crosses once? So go ahead, pause the video, think about that for a moment, and then we'll try the other graphs too. All right, as we look at this one, the vertical line has to be successful throughout your entire graph. So for example, here it passes, great, but you have to go all the way throughout the rest of your graph too. So it only crossed once there, only crossed once there. Yep, only once. This so far is looking good. Awesome, only one time. So because we went throughout the entire graph from left to right and it succeeded by only crossing once every single time, this would be a function. So your answer here would be yes. This graph is a function because it passes the vertical line test. Okay. And now let's quickly talk about the why this happens, whether it's a function or not. Well, right here, we have like Let's do a different vertical line so we can see it a little bit better. But suppose that you crossed your vertical line at x value being 2. So that's like saying 2 is going to, in this case, 1 at that point. And then 2 is trying to go to -1. Unfortunately, 2 cannot end up in 2 different places. 2 can only go to 1 spot. And so as a result, that's the why it's no. You can't have that repeating x value end up at 2 different places. And the vertical line test really confirms that visually. Now, as we look at this one, notice it only crosses 1 time, right? Well, only one x value is corresponding to 1 y value. Same thing here. And here, and here, and all throughout, you're having their own inputs, their own x values. And so as a result, there are no repeating x values going to 2 different outputs. So that is really the why the vertical line test works. On this one, if we drew our vertical lines, only crosses once. Here, only crosses once. Here it only crosses once, and here it only crosses once. So this would, in fact, pass the vertical line test. So yes, this is a function. This graph is a function because it passes our vertical line test. Now, again, this would be the 0.2, 3 right here. This guy would be, it looks like 3, 4. 3, 4. This one is 4, 4. And this one is 5, 6. Notice all different inputs. Vertical line test is passing. Yeah, you do see that repeating of the y value, but that's okay. That's totally fine. 2 different people going to the same place. And our final one, boom, fails right away. The moment that it fails just one time, where you see it crossing more than once, the moment is not a function. So no, this graph is not a function because it fails our vertical line test. And yes, on the homework, you would need to write like a little phrase like that, okay, and the test. So yeah, that is our 1.1 set of notes.